right, so like I said, if we were in class together, you would have an actual great big piece of paper like this with a curve drawn on here, and we would go through this. It's kind of like a hands-on explanation of why this formula is going to come, where it's going to come from. All right, so the goal today is to do Newton's method. Okay, we are going to use a calculator on it. So if you've got one, make sure you get that out, because after I get done with this demonstration, we'll definitely go straight to the calculator for the most part. All right, and if you've got to use the online calculator, that's fine too. All right, but this Newton's method, okay, basically what it was, you gotta think back. All right, think all the way back to what, 1500s, 1600s, when calculus was first being discovered. All right, obviously they didn't know everything we know now. They didn't have calculators, they didn't have computers, they didn't have things. They were discovering all of this mathematics. Okay, so Newton, we all know who that is. All right, this is his method because he came up with this. All right, now they knew about polynomial curves. Okay, so I've got some random polynomial curve here. Whoops, I moved my piece of paper. And they knew that it was going to cross the x-axis at some point, and they knew that was going to be a 0. All right, but because of their primitive methods and things that they had to work with, they couldn't necessarily find that. All right, when we find our zeros, if it's a nice little parabola that turns upside down, sometimes it's like what, like 2 and -2, or sometimes it's 4 and 6. They come out to whole numbers. All right, but if it's a polynomial curve that's not a nice curve, then that 0 is going to be some decimal, could be really, really long decimal. All right, so that was, they had problems with irrational numbers. They had problems with great big long decimals. They had problems finding things like that. All right, but things that they knew, a lot of how calculus got invented was they did it pictorially. They did it in drawings. They looked at graphs and they measured things, because they did have, like straight edges. They had compasses. They had things like that. Okay, so what I'm going to do is I'm going to kind of go through a little scenario here of how they went through a process that they went through to find that 0. And then I'm going to show you how what I'm doing from a graphical standpoint matches this formula, because basically Newton's method is a formula, and we are going to do this formula over and over and over and over. In other words, we're going to have several iterations of this formula, and everything that I do graphically is going to represent one iteration of the formula. Okay, so I'm going to try to color code this so it kind of makes sense. All right, so I did this here. I put that little dash on there just to kind of help me out here so that this works out nicely. All right, so they were trying to find this point. Okay, that was the 0. They were trying to find that. So what they had to do is they just had to randomly pick a point on the x-axis, because they didn't know, they don't know how close it was. They just randomly picked one. All right, and then they called this x(1). All right, and then what they did was they took their straight edge and they drew a line up to the curve. All right, now at this point, they knew about a tangent line. Okay, so they could geometrically draw a tangent line. Let's see how accurately I can get this here. So then after they did that, they drew a tangent line. All right, now that tangent line, if they draw it long enough, is going to cross the x-axis. Okay, so at this point, they called this x(2). All right, now I want you to notice, here's my 0. We can visually see it. Their guess was this far away. All right, they went up, drew a perpendicular line up to the curve. They drew that tangent line. This distance now is shorter or closer to the 0. All right, now that's one iteration. When I show you the modern formula we're going to use, that's one iteration of the formula. All right, and then what did they do? Well, they did the exact same thing. So I'm going to get rid of these pieces of paper underneath just so I can draw a straight line here. So then what did they do next? They did the exact same thing. So they took this and they came and drew a perpendicular line. Ooh, I almost don't have enough room. And they drew it down until it hit the curve. Oops, let's come up a little bit so you can see that. All right, till it hit the curve. And then they could draw the tangent line at that point. And again, minus my little faux pas right there, it crosses the x-axis again. That tangent line crosses again. So then there is x of 3. All right, now notice, let's take a look at what we started with. We started with, here's the 0, and they guessed this was the 0, and they're that far away. They did one iteration, they came up with this point, which is closer to the 0. Then they did another iteration, and they come up with this point. They're getting even closer and closer. So the more iterations that we do in this manner, the closer we are going to get to that 0, and eventually we find the 0. All right, so here is this. So what do? They take this, they draw a perpendicular line to the curve. All right, there's a point, and then what did they do? They draw the tangent line at that point. And then now I'm here. So after 4 iterations, I'm really, really close to that 0. If I did it again, I would be even closer. All right, now depending on, let's do it one more time. All right, so drop the perpendicular to the curve, draw the tangent line. Look how close that is. All right, and I'm doing this by hand, but look how close I am. So after start doing that, 4th iteration there, I am really, really close to finding that 0. So in essence, this is what the ancient people did back in like the 1600s to try to find the zeros of a function. They looked at it from a graphical standpoint, and they just kept doing this over and over and over and over. Okay. All right. Now, obviously, we're not going to do this. This is not an effective method. All right. Your textbook, initially, they're going to ask you to, they're going to give you a function, and then they're going to tell you to approximate the roots. All right. This right here is a guess. Okay, so you are going to have to guess a number for what you think the root is. All right, now, if you guess really, really far away, then this isn't going to work. So what I'm going to let you do when you're doing the questions out of the book, I'm going to let you put the function in your graphing calculator so that you know that the root is maybe, say, at 2.113 or something like that. All right, and then I want you to guess maybe 1.8 or 1.7. Guess a number that's a little bit away from the root. All right, either side, right or left. Okay, so then you'll be able to run your iterations and do this. Okay, so with that being said, now let's actually take a look at what the formula is going to look like and how we're going to do this. Okay, so I'm going to go ahead. We haven't dated it yet up to this point because of everything we've been doing. So let's go ahead and date it. And write down Newton's method, because these now like I didn't necessarily want you to go through that drawing that I just did since you didn't have paper, but now this is important stuff that you would want to write down. All right, I believe this is section 3-8 in our textbook. All right, so you've got the visual representation of what this was and what the point was and how it was working and why they were doing this. They were trying to find those zeros of the function. All right, so today what we're going to do is we're going to use the more modern version of this. We're going to use an iteration formula. Okay, so our iteration formula is going to look like x sub n plus 1 equals x sub n minus f of x sub n all over f prime x sub n. Okay, so I'll give you a minute to write that down. All right, now let's talk about this, okay? So you probably up to this point have not done a whole lot with iteration formulas, okay? But basically, this subscript of n, all right, if n is 1, that would be like the first iteration. You're going to work out the first iteration, and then it'll give you x sub 2, okay? Then you work it out again. When this goes to 2, and you're doing the second one, it provides you with the third point. When you do it a fourth time, it provides you with this, and you just keep doing it over and over and over. So what we're going to do is, like, we'll plug numbers in here. We're going to get an answer, then we're going to take this answer, we're going to plug it back in the formula. That's the iteration part. And we'll work it out again, spit out an answer, take this answer, put it back in this formula. All right. And this is very annoying to do if you try to do this by hand. All right, so that's why we're definitely going to do this on a graphing calculator. We're going to use that table of values and we're going to let it do the iteration over and over and over somewhat. Okay. All right, so that's the formula. This is on the formula sheet. All right, so at some point in time when you come back, I know like we're still on virtual now, but when we come back and we're in class, we will be taking some more memorization quizzes. All right, and so like the subscripts n, and n+1 really need to be there. So this is one of the formulas that will be on the memorization quizzes when we get to that point. All right, now let's kind of take a look at just kind of more what your textbook is going to do first. And then I will show you what it would look like if we take a written test with me. All right, so it's going to say use Newton's method to approximate the zeros. Could just be one or more than one of the function. And then your textbook is going to be very specific and tell you do 3 iterations or do 4 iterations. Okay, so let's just start with 3 iterations to begin with. Usually, depending on where that initial guess is, all right, 3 or 4 is going to get you to the root. And you're going to see some patterns when we start doing this on the calculator. You're going to see some patterns. All right, and then you're going to be able to tell how many iterations it was, because what's going to happen is you're going to keep getting the same number. You just get more decimal approximations. All right, so we're going to do a really, really simple one here to begin with. All right, let's suppose they give you the function x squared minus 2. Now, we all know that we can find the roots to this very easily, okay? But let's assume that it was some great big long polynomial curve and we could not find the roots. We could not find the zeros of this function, okay? So I'm going to, let's rewrite the formula over here. X of n+1 is equal to x of n minus f of x of n all over f prime x of n. Okay, so clearly in our formula, we need our function and we need our derivative. So the first thing you need to do, calculate that derivative. I'm going to calculate the derivative. This is a nice simple little derivative, 2x. Okay, now I need to generate my formula that I'm going to put in the graphing calculator. I'm going to put it in y1. All right, so I'm going to look at just this portion of that formula, because that's what I'm going to have the calculator do all of the work at, and then it's going to spit out this in the XY table. All right, so for this right here, x of n, this is always going to be an x. So I'm going to have the formula x minus, this is the original function. All right, so my original function is x squared minus 2. And then this is the derivative, so 2x. All right, so this is what is going to get plugged into your graphing calculator. Okay. Now let's go ahead. Do I want to pull this up at this point? Yeah, let's do this. I'm going to try to zoom in a little bit, but not tons. Let me just see the calculator. Can you guys see my screen pretty good on the calculator?
Yeah.
Okay. All right, so I'm going to go into y equals, and I have junk in there already, so I'm going to clear it out. I'm going to literally put this in here. So I'm going to go x minus, I'm going to put my fraction in there. I'm going to put x squared minus 2 on the top. I'm going to put 2x on the bottom. Okay, so literally I am just going to put it in my y1. Okay, now I'm going to go over to my table of values. So second table. All right, now I don't know. Let's see. How did I have my table set? I have my table set and yours probably is too on ask. All right, which is fine. We want it on ask. Okay, we want the dependent on auto. Okay, let's go back to the table. And it doesn't clear out on mine, so I got a bunch of stuff in there. Just get rid of all those numbers because I don't want those numbers in there. Okay. Now, what your textbook is going to do is they're going to tell you to guess, use that initial guess at what you think the root or zero is. All right, now can we do this in our head? Like, because you don't need to actually use graphic calculator. Can I do this? Can I solve this in my head? Can I add 2 to both sides, take the square root of both sides? So it's going to be the square root of 2, right? Square root of 2 is what, 1.4 something? All right, so let's guess, let's start our initial guess at maybe say 1.2. All right, every one of you, when you do the first 4 questions in the homework, you're going to start with a different guess. And it doesn't matter. If we all started with a different guess, we're still all going to end up with the same 0, the same answer, because this iteration formula of doing this over and over and over, all right, is going to ultimately spit out the actual 0 of the function. All right, so actually, why don't we try that? Since you all are at home and I'm here, why don't we all pick a different number? All right, we know the root's going to be 1.4 something, okay, because square root of 2. All right, so why doesn't somebody start with 0.9, somebody else start with 1.2, someone else start with, I don't know, 1.5, 1.6. All right, I'm going to start with 1.2. So I'm going to put 1.2 in. I'm up there at the top. I'm going to put 1.2 in, okay? Now, it spit out a number. Okay, if I arrow over to the number, I can look down here and see the exact great big long number. All right, when I put 1.2 in, it gave me 1.433333333. All right, so then if I want to go out 3 places, I'm going to take that answer that it just gave me and go 1.4333. That's going out. I went 4 places. So then whatever that answer is, you put in as your next x. All right, and then what am I getting? I'm getting 1.4143402. 06, I can't read my own numbers. So again, if I go out and I put 4143 in as my next number, 1.4143. All right, now what did I get? 1.4142. Okay, now let's go out and put the 4 decimals in again. 1.4142. Look at that number. And then look at that number. Okay. Look way, way out there. Okay. If I do it again. So if I put that number again, 1.4142, it's getting closer and closer. But can we not see a pattern here? Let me zoom in a little bit more in case you can't see that. Ooh, that's not going to be a good place to put it. Let's put it right there. Okay. Look at the number at the bottom. It's getting closer and closer to the square root of 2. All right, so on this one, when I guessed 1.2, I come up with 1.433. I put that answer in as the second one, it spits out this. I take that answer, I put it in for x, it spits out this. So to see how eventually after you do so many iterations, you can assume now that the 0 is approximately 1.414. Okay? Does that make sense with everybody? I'm not getting any feedback, and you all are sitting at home. Stop sharing. I'm going to go so I can all see you. Okay, now, did somebody start with something other than 1.2? Somebody tell me. Did someone start with something other than 1.2?
I started with 1.5.
Okay, and did you get to 1.414?
Yes.
Yeah, so you were on the right-hand side. Thank you very much. I appreciate that. A little bit of feedback this morning. Okay, so now, what this would look like if you were actually, let's go back to sharing, if you were actually taking a test, written test for me, okay? This is just an old test that I have given. Let's zoom right in. Okay, so this is how I have set this question up in the past. All right, it's clearly been on the calculator portion. All right, and it just says complete 4 iterations of Newton's method for the function using the 2 given initial guesses. Now, on a testing environment, I am going to give you the initial guesses, because if not, and if everybody in the room picked a different initial guess, then all of these answers on the test would be different for every individual person. So it's just easier to guess or to grade. All right, so in this one, because we know that some functions have 2 roots, right? This is a parabola, all right, upright parabola, and as long as that vertex is below the x-axis, it's going to cross in 2 different places. All right. And if it's somewhat symmetrical around the y-axis, doesn't have to be perfectly symmetrical, but one of them could be negative and one of them could be positive. So you would have to run Newton's method for each possible root. Okay, so that's what I'm doing here. I'm giving the initial guesses. All right, and then I set a table up for you, and I'm telling you to round to 3 places here, and I even put the negative 1.9 in here. And then you have to have the formula memorized, the x minus the function over the derivative. All right, you calculate that, you put it in there, and then all you would have to do is write out the answers. But as you can see here from this table, it started at negative 1.8, goes to negative 1.011, and then finally goes down to 1. Okay, so when it starts to level off and you keep getting that same decimal over and over and over and over, then you have hit the root. All right, and then this table over here set up with the 2.1, and then you again would create the formula, put it in your calculator, generate the numbers. It starts out with that 1.7 and then jump down to 1.66. All right, but 6677 and then 6667. All right, and then you get that repeat. All right, so as soon as the about 4 decimals out starts to repeat, you have found the 0. Okay, so like I said, since we're in the virtual learning right now, you won't be taking a written chapter 3 test. And this is not something that I'm going to how like some questions I just keep asking you over and over and over and over. I'm probably not going to do that. It probably is, this will probably not show up on the Math Excel because the Math Excel on this, you have to have the decimal you enter like perfect or it counts it wrong. And I don't like the question in Math Excel at all. So I will probably wait until we get to chapter 4. We're back in person, and then I'll put one of these on an assessment, but we're not going to like do this tons and tons and tons. Okay, it is something that is in the Calc 1 curriculum. You need to understand it. If someone talks about Newton's method, you need to understand, oh yeah, hey, that's that iteration formula, which I can use to find the zeros of a function. Okay, but this usually does not show up on the AP test. This usually does not show up on the ACP test. All right, so actually just hopefully a fun little activity. I mean, we don't get a lot of being able to, I mean, I try to show you graphical representations, all right, but this was kind of more of a, well, how did they do this back in the 1600s? They didn't have calculators, and then yet they had to find these great big long decimals. They had to work at it. So they did it from a graphical standpoint. Okay, so a different kind of lesson. I'm sure that doing this virtually, it lost some of the enthusiasm of this. Had you been in the room, all right, like in the past when we've been in the room and everybody's had their great big piece of paper and everyone has drawn it out with a ruler and everything, it has always been a fun day in the past. And so little less exciting because you guys are at home, we're not in person. But yeah, so that's pretty simple concept right there. Now, I do want to do one extra thing today, very, very short. I want to introduce you to something called differentials. Because it's like, and it like baby step into it. Like I want you to know what a differential looks like, what the equation looks like. All right, this was supposed to be part of Mondays, but I want Mondays to go kind of short so you'll have more time to review and prepare for the Math Excel quizzes coming up. So I want to go ahead and do the differentials today because this won't take very long. So I'm going to go back to sharing. It's 10:05. I promise I won't keep you over. Okay. All right, let's make sure I'm zoomed out so we see the whole screen. Okay, there we go. All right. Now, like I said, this is not going to be an official long thing. I just kind of want to get this word out there for you. All right, with a little definition, and it's a very easy concept here. All right, so for a definition. Okay, so we're going to let y equal f of x represent, can't spell represent a function that is differentiable on an open interval containing x. The differential of x. All right, and that's going to be referred to as dx. The differential of x dx is any non-zero real number the differential of y, we're going to denote that with a dy, is equal to f prime of x dx. Okay, so basically what I have here is the differential equation. I have an equation written and it's referred to as a differential equation. We're going to go more into that later. All right, this is differential form. When I have a dy is equal to something, which happens to be the derivative, and then a dx that follows that, then this is a differential equation. It's in differential form. All right, now later on, like I don't even know what chapter it is. It's going to be quite a while from now. All right, we will solve differential equations. We're going to only solve first order differential equations, and we're only going to solve ones that are separable. Okay, because if you go to college and you end up taking like Calc 1, Calc 2, Calc 3, there's a whole entire course. It's usually called Diffie-Qs. It's differential equations where like you can solve second order and third order, and it gets really intense at that point because you're about at a Calc 3 level. All right, so we're just going to focus on first order differential equations. We're going to solve them, only the ones that are separable because that makes it easier. I mean, this is just a Calc 1 class. Now, for this part, you're not going to do this homework until Monday, okay? Because I didn't separate and put extra homework on today or anything. I just want to talk about this today. All I'm going to have you do is you're going to be given a function, and then it's going to tell you to rewrite it basically in differential form. So you're going to write it in this form. So the questions in this initial introduction into what a differential equation is just going to be really, really simple. All right, so we'll do one question here. Let's see, give you the directions. Let's say it says find the differential dy for the given function. All right, that's probably the only thing your book's going to say. I'm going to say use differential form just in our notes, just so that that'll help you remember as you go back and look at your notes to study or something. Okay. And all the problems are going to be, we're going to do like a super, super easy ones. So let's suppose I have a y equals an x squared, like a really nice little baby function here. All right. Our differential form, all right, is going to be dy is equal to the derivative times the dx. That's the differential form. So literally that's all you have to do. If you know the function, can you calculate the derivative? Yep. So the derivative is what, 2x right there? So I know my derivative. Okay, now can I write it in differential form? Yep, just make it look like that. Make it dy is equal to, put the derivative in, 2x, throw the dx afterwards. All right, so initially, that's the only thing I want you to do because I just want you to get used to what this looks like. Okay, and the fact that this is a differential equation. All right, we will get to them. These obviously are very baby, nice little tiny differential equations, but literally this is all there is to it. Let's do one more just to make sure. All right, y equals, say, sine 3x. Okay, so if I want to write this in differential form, all right, first thing I need to do is calculate that derivative. All right, now, can we do this? This is going to be a what? Chain rule, right? So derivative of sine, leave the inside alone. So derivative of sine is cosine. Leave the inside alone, and then times the derivative on the inside. Derivative of that inside is 3, but instead of writing it over here, I'm just going to go ahead and write it in front because we know it's going to go in front. So there's my derivative right there. And then differential form, dy is equal to 3 cosine 3x, and then throw on that dx on there. All right. So that's why, this was that easy. And I just, like I said, I just want to introduce the idea of what a differential equation is. This is what it looks like. It'll be in this form. You got the dy, you got the dx in there. All right. And of course, these are, like I said, relatively simple right here. Okay. But how we form that differential equation, if you later, like a month from now, when we start to solve these things, if you can remember back to this nice little introduction, well, how did we get to this point? It's going to then help you know how to solve it, because eventually when we're going to solve this, right? That's what we do. We solve equations. So we're going to have a differential equation, and then you're going to solve it. Okay. All right. So these type of questions will be on like Monday's homework.